but it hasn't been changed in any way. So when a shape has just been moved left and right and up and down, we call that a translation. So we say a shape has been translated if it has just been moved around. It hasn't been rotated or reflected, it's just been moved. The first example here says describe fully the single transformation that maps triangle A onto triangle B. So we're saying it's a translation. It's the same shape and it's just been moved. So it's a translation. And how far has it moved? How far has shape A moved to get to shape B? So if I look at this top left corner, I'm going to say it's gone 1, 2, 3, 4, 5, 6, 7 left and 2 up. So it's gone 7 to the left and it's gone 2 up. We can write this as a vector. So by the vector, and I write the change in the x on top. So it's gone 7 to the left. That's back 7 on the x-axis. Minus 7. That's the change in the x. And the change in the y is up 2 spaces. So it's a translation by the vector negative 7, 2. Back 7 on the x, up 2 on the y. Back 7 or left 7, up 2. Here's one for you to try. So describe the transformation from triangle A to triangle B again. So again, we've got a translation. It's the same shape and it's been moved. So it's a translation. How far has it moved? So I'm going to use the top corner again. So how about the x, the change in the x? It's gone 1, 2, 3, 4, 5, 6 to the right. And 2 up. So it's a translation by the vector. So the change in the x is plus 6. It's gone plus 6 on the x-axis and plus 2 for the y's. So it's a translation by the vector 6, 2. Here's another question. So describe the transformation that maps triangle A onto triangle B. We're doing the same thing. So I'm going to take the top corner again, the top left. How far has it moved? 1, 2, 3, 4 left. So that's minus 4 in the x direction. And 1, 2, 3, 4 down. Minus 4 in the y direction. So minus 4 in the x, and then minus 4 in the y. So it's a translation. It's just been moved by the vector. So 4 left, that's minus 4 in the x direction, and 4 down, minus 4 in the y direction. So it's a translation by the vector negative 4, negative 4. And one for you to try. So give this one a go. So again, we've got a translation. And I'm going to put by the vector. And then I'm going to work out how far it's moved. So pick the same point on both triangles. It doesn't matter which point you pick. You'll get the same answer. So from A to B, it's gone 1, 2, 3, 4, 5 left. And 1, 2, 3, 4, 5 up. So 5 to the left is negative 5 in the x direction. Positive x is to the right, negative x is to the left. And it's gone up 5, which is positive 5 in the y direction. Positives are up, negatives are down. This is a different question now. We have to translate the shape. So we have to do the moving. So we need to translate shape A by the vector 3, negative 2. So what does that mean? That's 3 to the right and, well, 2 down. So 3 right, 3 in the positive x direction, and then down 2. So 2 in the negative y direction. So let's pick a point. I'm going to pick the bottom right. I'm going 3 to the right and 2 down. So that's going to be the bottom right of my shape. And then I could just draw it on from here. You could do this with every point, or you could just draw the shape on once you've worked out one of the points. It doesn't matter which one. So I've drawn it on, and I'll check with another point. So from the top left, 3 right, 1, 2, 3, and 2 down gets me to there. So that is shape A translated by the vector 3, -2. One for you to try. So give this one a go. So translate the shape by the vector -2, 3. So that means 2 to the left, -2 in the x direction, 2 left, and 3 up. So let's pick a point and go 2 left and 3 up. So that's my top left corner. And then I can just draw the shape on. And there is our shape. We can check with another point. So 2 left, 3 up. And another one of these. So translate shape A by the vector -2, -3. So that's going to be 2 to the left, -2 in the x direction, and 3 down, -3 in the y direction. So negative in the x direction means left, positive means right, and in the y direction, positives up and negatives down. So we're going 2 left, 3 down. So pick a point, go 2 left, 1, 2, 3 down, and then we can draw the shape on. So it goes 3 along the top, 2 down. So that's our triangle, and I'll check with another point. So 2 left, 3 down. And it should work for all points. 2 left, 3 down. Okay, one for you to try. So translate shape A by the vector 4, -2. So 4, -2 means 4 to the right, +4 in the x, and 2 down, -2 in the y direction. So we're going to go 4 to the right, 1, 2, 3, 4, and 2 down. So that's the top right. So it goes back 3, down 2, and join up the triangle. And we can check with another point. So 4 right, 1, 2, 3, 4, and 2 down. 4 right, 1, 2, 3, 4, 2 down. Okay, 2 questions to finish up. So give these ones a go. Question 1 says translate shape A by the vector -4, -2. So -4, -2. So the top one's the x change, the change in the x. So it's going 4 left. So positive is right, where the positive x numbers are, and negative is left. And for the y change, positive means go up, negative means go down. So it's 2 down. So we're taking any of the points and moving them 4 to the left and 2 down. And if we did that for every point, so 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. We would make our triangle. And question 2, describe fully the single transformation that maps triangle A onto triangle B. So it is a translation. And I'm going to write by the vector, and then I'm going to figure out how far it's moved. So pick a point and we can say it's gone 1, 2, 3, 4, 5 to the right. So that's plus 5 in the x direction, and it's gone down 1, 2, 3, 4. So down 4 in the y direction. So it's a translation by the vector 5, negative 4. And if you picked any of the points, you would get the same vector. So 1, 2, 3, 4, 5, 1, 2, 3, 4.